Okay, so our next review topic for the end of the semester for AQR is our exponent rules. So I just wanted to real quick run through the rules. They all have names, but personally I don't care what they're called. I just care what they do. So that's what I'm going to show you. Because it's great to remember those names, and it does make it sound like you know what you're doing and then people think you're smart and all that. But really, we care about what they do. So, da-da-da. I should rename them. They would be the Spiller rules. Okay, the first one that we're going to talk about is probably called the identity property. Pretty sure it is. This one says that if you have anything raised to the power of 0, it's just a 1. So if you have like 4 to the 0 power, that's just a 1. If you have 5,058 to the 0 power, that looks like a 6. Let me make that a 0. There you go. It's still just a 1. Or if you have an x to the 0, it's all just 1. So that doesn't change. Anything to the 0 power is 1. Okay, easy enough. Da-da-da, we're moving right along. Next rule. This one is, I think it's called the addition rule. That's what I'm going to call it. Let's say you have a to the n times a to the m. Now this only works if the base is the same. So the base here is our a. So if these are the same, then when you multiply them and they have exponents, the exponents add. So this would be a to the n plus m. So this is handy. So like let's say you have x squared times x to the 5th. Well, this would be x to the 2 plus 5. So that would be x to the 7th. I'm sure you've seen those. You've probably seen all of these. It's just been a while. Okay, so that's easy enough. Same thing if you divide. It's the same basic thing, so I'm just going to go ahead and do that now. If you have a to the n divided by a to the m, and yeah, it looks like a fraction, but this is just division. You could write it with a little divide sign, but who even uses those after elementary school? I really don't know. Okay, so a to the n divided by a to the m, you just subtract. So this would be a to the n minus m. So this was like if you had x to the 6th divided by x to the 1, this would be x to the 6 minus 1, or it would just be x to the 5th. It's probably called the division rule. I don't know. It's called that now. Okay. 2 rules. We have those out of the way. Again, we are moving right along. Hooray! So fast. Okay. Now let's get into some of the other ones. So this one, if you have an exponent, so you have a to the n, and you raise it to the power of something. So let's raise it to the power of m. If you raise an exponent to the power, what you end up doing is you multiply those exponents. So a to the n to the power of m is a to the n times m. So this makes sense. Like let's say you had x squared and you raise that to the power of 3. Well, what that is this is x squared times x squared times x squared, right? So that's xx times xx times xx. Well, if you count those up, there are 6 of those. So this is x to the 6th, which is the same thing as 2 times 3, right? So this is x to the 2 times 3. So that's x to the 6th. On any of these rules, if you don't totally believe it, you can write it out like this way. You can expand it out like xx times xx times xx. So if I go back, like for the division rule, like let's say I didn't believe that I could do a to the 3 over a squared. If I didn't remember, I could always just go, okay, so there are 3 of those, right, because my exponent's a 3. There are 2 of these in the bottom because my exponent is a 2. And if I do that, then one of these x's will cancel one of those. This x will divide out and make a 1. And I'm left with x, right? But x to the 3, which is, okay, x to the 3 minus 2 is x to the 1, which is the same thing, right? So x to the 3 minus 2 equals just x. If you have an x like that, that's an understood 1. So you don't have to write the 1. You can, but probably people would be like, oh my gosh, she doesn't know what she's doing. Yeah, you'd get all the mean girl math version. Okay, hooray, so we have that. Our next one is weird. These are 2 kind of weirdish ones, so that's why we're going to do those next. That's why I saved the weirdest for last. Hooray. Okay. let's say you have a negative exponent. Oh no, this is terrible. My mom warned me about these things. Actually, she didn't. I don't even know if my mom knows what a negative exponent is. Okay, let's say we have a to the negative n. Uh-oh. So this is not negative a to the n. That's not what it is. All a negative exponent does is a negative exponent changes position in a fraction. So this, since it's just a normal a, this negative is going to make it a fraction, and it's going to put them in the bottom and send down or up. Confusing enough? Okay, if you have a to the negative n, what this really is, the negative puts it in the bottom. So a to the negative n is 1 over a to the n. So my negative goes away, and my a to the n goes to the bottom of a fraction. So if I have x to the negative 1, this is, my negative goes away, I send it to the bottom of the fraction, this is just 1 over x. If I have x to the negative 3, the negative goes away, and my x to the 3 goes in the bottom. If you have something like this, let's say you have 2x to the negative 3. Well, my 2 doesn't have an exponent, only just the x, right? So what happens is the 2 stays in the top, and only my x to the negative 3 goes to the bottom, and the negative goes away. So this would be 2 over x to the 3. So that's what a negative does, is it just changes its position. So if you start out with it in a fraction, so let's say you have this, let's say you have 1 over a to the negative m. Well, what this does is the negative, again, changes position, and the negative goes away. So in this case, it's going to be a to the m, and you could put over 1, but this is really just a to the m. So like, let's say you had 3 over 2x to the negative 4. Well, the x to the negative 4 is the only thing that has the negative exponent, so my 3 and my 2 keep their same positions. So I have a 3 up here, and I have a 2 down here, and then this x to the negative 4, the negative goes away, and my x to the 4th flips up to the top. So if you have a negative and then you're not in a fraction, it'll send you to the bottom. Or if you're in the top of the fraction, it'll send you to the bottom. If you have a negative exponent in the bottom of a fraction, it flips it up to the top. So the negative just changes position, right, within the fraction. Okay, and then in the last one that we're going to do really goes into roots, like square roots, cube roots, all that, but it also concerns exponents. So a square root, like if we write it like that, there's an understood 2, right? Okay, so that's fine and good, but sometimes we want to write that in exponent form. So this is our radical form, because it's so rad, man. Okay, so this is radical form. And the radical is just that symbol, that's radical. It could be a square root, it could be a cube root, it could be a 25th root, doesn't matter, that's the radical symbol. So we want to put this into exponent form. What we do is we have an exponent for that. So exponent form. Here we go, I'll show you this. Okay, so this says if you have something like this, x to the n over m. Uh-oh. Now we've got exponents and their fractions, and this day just took a turn, right? Okay, not really. So what do we do? That's the exponent form. We can switch back and forth between exponent and radical. What happens is whatever's in the bottom of the fraction, that comes over here and goes to your root. So this is here. Whatever's in the top of the fraction stays with the x, and that goes inside. So x to the n over m is the same thing as the m root of x to the n. So if you have x to the 1/3, this is the same thing. So x to the 1 goes inside, and we don't need to write that 1. The 3 is in the bottom of the fraction, so that goes right here. This is actually really handy, and I actually use this a lot, because if you have something and you need to take a root in a calculator, but you don't remember where these higher roots are, I don't want to have to spend 10 minutes looking through the directory of the calculator or the little catalog thing trying to find the exponent with the little dot so I could fill it in, but it's no big deal. I just put it in as a fraction. So if I need to take x to the fifth, if I need the fifth root of x, sorry, or like let's say I need the fifth root of 12. In my calculator, I can just go ahead and put it in an exponent form, right? So this is 12, and this is an understood 1 right here, so that's 1. The 5 is on the root, so this is 12 to the 1/5. So all I would have to do is I would go in my calculator, I'd do 12, my little raised to the power of, I usually put it in parentheses because I don't want to mess this up. I would do 1 over 5, and it would give me an answer. I'll show you the answer just one moment. Let me put this in here. 12 to the power of 1 divided by 5 gives me 1.6437 blah blah blah. So I'm going to put 1.64. Da-da-da. So that's actually, like, this rule is actually super handy, and I actually have used this quite a bit. So if I wanted to say, like, let's say I had the 25th root of x to the third. Well, that's ugly, but I could put it over in an exponent form, and I don't really care, right? Because fractions, roots, it doesn't matter. They're just numbers. We can all live in peace. It's okay. Okay, so I can go x. I know it's going to be a fraction. The part that's inside with the x right here goes up top. The part that's outside right here goes in the bottom. So that's just x to the 3 over 25. And it's no big deal. We can go back and forth with that. Okay, so that concludes our review of the exponent rules. Hooray, exponents!